The objective for this video is to learn how to conduct a Wilcoxon Signed Rank test about two dependent samples. The Wilcoxon Signed Rank test is a non-parametric test used to test whether two dependent samples have been selected from two populations having the same distributions. The assumptions for the Wilcoxon Signed Rank test are: 1. The paired data have been obtained using a random sample. 2. The population of differences has a distribution that is approximately symmetric. A random sample of legal costs in thousands of dollars for school districts for 2 recent consecutive years is shown. At alpha equal to 0.05, is there a difference in the costs? Step 1 is to state the hypotheses. The null hypothesis is that there is no difference in the legal costs between years 1 and 2 for the school districts. The alternative hypothesis is there is a difference in the legal costs between years 1 and 2 for the school districts. The claim in this case is in the alternative hypothesis. Step 2 is to find the critical value. When the sample size is no more than 30, use the critical values for the Wilcoxon Signed Rank test table to find the critical value. When the sample size exceeds 30, use the standard normal distribution table. Since our sample size is less than 30, we will use the critical values for the Wilcoxon Signed Rank test table. Our sample size is 8. We have a two-tailed test with a 0.05 level of significance. The column for the two-tailed test with alpha equal to 0.05 intersects the row where n is equal to 8 at the critical value 4. Step 3 is to compute the test value. In order to calculate the test value, we will construct a table that contains the two data sets, a column for their differences, a column for the absolute value of the differences, the rank for each absolute value, and then a column where we will apply the positive or negative from the difference column to the values in the rank column. We will subtract the year 2 value from the year 1 value and find a difference of negative 30 in the first row. The absolute value of negative 30 is 30, which we will place in the next column. We will carry out this process for each row in the table. Next, we will find the rank for each of the values in the absolute value column. Notice that the absolute value 8 occurs twice. Instead of assigning a ranking of 2 and 3 to these equal values, we will instead average the rankings for an equal rank of 2.5 assigned to each. The next step is to apply the plus or minus sign from the difference column to the value in the rank column for each row. We will then find the sum for the positive rankings and the sum for the negative rankings. There is only one row with a positive ranking, so that sum is 2.5. The sum for the negative rankings is negative 33.5. Select the smaller of the absolute values of the sums and use it as the test value. So our test value will be 2.5. Step 4 is to make the decision. The Wilcoxon Signed Rank test is an example of a test where we should reject the null hypothesis if the test value is less than or equal to the critical value. Since 2.5 is less than 4, we should reject the null hypothesis. Step 5 is to summarize the results. Since we will reject the null hypothesis, our conclusion should be that there is sufficient evidence to conclude a difference exists in legal costs. In this video, we learned how to conduct a Wilcoxon Signed Rank test about two dependent samples.